Hello, my name is Luke Kolik. I am a second-year student at Louisiana Tech University. This is my pen plotter project for manufacturing processes. I have chosen to voice over using text-to-speech to improve clarity. The manufacturing process's pen plotter is a miniature CNC machine that is capable of 3-axis movement, the Y being controlled by a lead screw and the X being belt-driven. It is powered by a 12-volt DC source. It uses the same Arduino used in the 120 series of classes, but modified with the component called a CNC shield. The Arduino interprets commands using G-code, the same language spoken by professional multi-million-dollar processing machines. The microcontroller uses these commands with the aid of the CNC shield to drive the stepper motors that enable motion. I chose a rack and pinion mechanism for my plotter's Z-axis, since I believed it to be the easiest way to generate that vertical motion without having to construct a lead screw system. The next constraint was maximizing rigidity so that the pen does not vibrate in this system and fail to follow the G-code. I accomplished this by mounting the motor housing and the system that allows the rack and pinion to translate as one module, so that motion is constrained in every direction except the desired one. It was a pretty tall task at first, but ultimately, with some design iteration of the different holders, the system turned out very well. The first problems I encountered with my plotter were its initial iterations. It is almost inevitable that a fully optimized part will take multiple prototypes to achieve a desired result. The red components are the first iterations of my limit switch system, while the gray ones are the first iterations of my Z-axis. As you can see, my initial gear design actually made it into the final product. Sometimes, what would otherwise be a flaw can be improved through further processing of materials, which I used frequently when tolerances didn't meet. If you want something clean, I would recommend printing it big and sanding it down or melting parts of it. My gear uses a base that I melted to generate a perfect press fit without needing further constraint, and my rack's mesh with the housing was sanded down to stop it from wobbling, and then I applied dry lube to reduce friction in the channel so that the smaller stepper motor's low torque could be overcome. If I could do it all over again, I would spend more time thinking about how my Z-axis would incorporate with my plotter bed. The way my system turned out resulted in an overall pretty small print area of just 60 by 63 millimeters. I would definitely recommend getting the first iteration of your Z-axis done as soon as possible, since I do not know a single student who managed to get it working with no possible improvements or design flaws on their first attempt. Additionally, making things modular so reprints take less time and use less material is a good idea where possible. I knew a few friends who had systems that were built to such tolerances that one crack resulted in an entire new setup needing to be reprinted. I tested a number of different pens and ultimately settled on a gel pen. I would recommend using a clamp that can be tightened and loosened unless you have confidence in your pen. It allows you to test all types of pens and see what works with the levels of contact pressure your axis is producing. Rigidity is also very important for the quality of your final product, so constraining motion in a similar manner is recommended, whether you go with the rack and pinion, lead screw, or some other linear motion system. Ultimately, this project took a lot longer than I thought it would have, but I learned a lot about the engineering process from it. While some nights ran long, I had a lot of fun. The satisfaction from a working design that you came up with feels amazing, and the skills developed throughout the process will actively aid me in industry.